This is R.D. Sharma solution, class 12, chapter 11. Differentiation exercises 11.1. Differentiate the following functions from the first principles. X square e raised to the power x. Same thing we have to do. If you want a reference, I have given you a reference on the left. And those who want to understand how it is being done, then this is the fx. This is actual function we have to differentiate. And when we differentiate, we have to use this fx plus h. So I am adding h with the x and writing the function which is called as fx plus h. And then subtracting the original function which is our fx function. And it is nothing but x square e raised to the power x. It is not minus x, I'll just change it. Division by h and limit h tends to 0. Now these two things will be used. Okay, this limit h tends to 0 and division by h I am going to use wherever it is required. But whenever you are writing, you have to write this limit h tends to 0 and divide by h every step, in every step. So now let us open x plus h whole square, a square plus b square plus 2ab, x square plus h square plus 2xh. Multiply it with e to the power x plus h. So this is how it will be formed. Then we have this minus x square e raised power x. Now let us take this x square term together. When we take x square, so e raised x plus h, and then we have minus e raised to the power x. Then we have this h square e raised power x plus h, h square into e raised power x plus h. Then we have this 2xh e raised to the power again x plus h. So there is no commonality here. So let us see this one. Now this is what we have solved earlier also, e raised to the power. So whatever we do is we will take the second term common. So when you take this e raised x common, so it will be e raised x plus h divided by e raised x and minus 1. Okay. So now this one, we have a relationship. And that relationship we have used when we were solving the e raised to the power x questions. And the equation or the identity is e raised to the power h minus 1 by h is equal to 1 when limit h tends to 0. Okay. So this x square we have taken common, e raised to the power x we are taking common from here. When we take e raised to the power x common, this e raised power x plus h divided by e to the power x, this goes up. So e raised x plus h minus x. So e raised h minus 1. And then we have x square e raised h minus 1. And please remember there was a h in the denominator already. So I am taking h for every term. The first thing which we will do is divide by h and multiply by h. That's what we do normally. But still because we have a h in the denominator already, so what we do, e raised h minus 1 by h, this is already there, so we don't have to multiply by h, and limit h tends to 0 is going to be applied, and this whole term which is in the circle or which is in the boundary is going to be 1. So this becomes 1. So what is remaining is x square into e to the power x for the first term. Second term h, just cancel it out, h into e to the power x plus h it will be. And the third term hh you can cancel, 2x into e raised x plus h it will be. So just apply the limit in these two terms and make the h as 0. So when you take this one, this is going to be 0 and h is 0 here, so only e to the power x will remain, 2x into e to the power x. So only remaining is these two terms, middle term becomes 0. So this is e to the power x, I am taking e to the power x common. It is going to be x square plus 2x. That is your final answer, final solution. Differentiate the following functions from first principles, log, cosec x. And if you remember, we have already done a question in this exercise which was log cos x. So this question, the way of solving or the steps we are going to take will be same, log cos x. For those who want to do themselves, I have given a reference on the left. But those who wants to understand, let us understand it by fx plus h minus fx by h, limit h tends to 0. This is what we have to apply. So log cosec x plus h minus log cosec x. So log cosec x plus h minus log cosec x and divided by h, that is the first principle when we have limit h tends to 0. I hope you will be able to write this, and this division by h and limit h tends to 0, as I was telling earlier also, we will be using it wherever it is wanted, but you have to use it, write it everywhere. You know that log x minus log y is nothing but log x by y. This is the property of log. So we have log cosec x plus h. You can write it in the numerator and cosec x in the denominator. So log a minus log b. So I am just writing the numerator now and I am trying to solve this. Then we will use this division by h and limit h tends to 0. So now this cosec can be converted into sine because sine and cos is better to deal rather than going for cosec or sec. So we have cosec theta is 1 by sine theta. So this will be inverted with a sine. So sine x in the numerator and sine x plus h in the denominator. Okay. Now let us, what can we do? We cannot do anything right now. So the best way is to apply the known identity log 1 plus x divided by x when x is tending to 0 is equal to 1. So log 1 plus x divided by x, when we apply limit x tends to 0, it is going to be 1. So you can add a 1 and subtract 1 by yourself. So we have to do it by ourselves. Okay. So this sine x, this 1 plus whatever is there is your x and division by x. So 1 plus whole of it, which I'm circling right now, is what we have to divide also. So log 1 plus, let us solve it now, sin x minus sin x plus h divided by sin x plus h. So sin x, this is whole your, you can say whatever is after 1 plus, that has to be, if you just say it is theta, log 1 plus theta by theta, theta tends to 0. So this is whole theta, you can say. Now we need this theta in the denominator also because this is log 1 plus theta by theta. That is going to be 1. So you just call it as, say, theta. I am writing, assume that this is theta. I am writing theta in the denominator. Just assume that this is theta, that whole term after 1 plus. So we have to have a theta in the numerator also, that is the whole term. Now this whole term, this total 1 plus, I am calling this sin x minus sin x plus h by sin x plus h as theta. So when theta tends to 0 or h tends to 0, log 1 plus this term divided by that term is going to be 1. So only this theta, that this term will remain. Okay, we have applied log 1 plus theta by theta. So only theta will remain. I hope you got the idea. So we have introduced a term. So only this term, this theta, which is actually sin x minus sin x plus h divided by sin x plus h, that is going to be solved. And for that you have to know the value of sin a minus sin b. Sin a minus sin b is nothing but 2 cos a plus b by 2 sin a minus by 2. So these things you have to learn. If you don't learn, you can just learn by heart. Well, there are tricks to remember these. But right now, I hope that you know that sin a minus sin b is what? So 2 cos x plus h by 2, 2x plus h by 2. Then we have sin a minus b. That is x minus h. So you have sin minus h remaining. Okay, sin minus h by 2 because it is a minus b by 2. So you have sin minus theta is minus sin theta. You know already that. So I am taking this negative outside and I am just writing sin h by 2. Sin minus theta is minus sin theta, that is why minus I have taken in the front, and sin h by 2. Now this term you can just apply, see, wherever when you put h as 0, there is no undescribable or indeterminate term, you can always apply h as 0. Now we have a denominator also, we will be talking about that in a short while. So minus 2 cos 2x plus h by 2, and then, so we can safely apply h as 0 here. So you can apply it h tends to 0 here. Here also sin x plus h. Here also, you know, if you apply sin h tends to 0, so sin x will remain. So there is no problem. But here we have sin h by 2. And please remember, I told you in the beginning there was a h in the denominator because first principle has a h in the denominator. So just divide by 2 and multiply by 2 because we want a h by 2 in the denominator also. Sin theta by theta, limit theta tends to 0 is going to be 1. That you already know. So sin h by 2 by h by 2 is going to be 1. I am applying limit theta tends to 0 here. H tends to 0 for example. In this case, 2 gets cancelled. You just have a negative. Now I am applying the h tends to 0 for cos 2x plus h by 2 and sin x plus h. So apply the limit here. H is going to be 0. 2x by 2 is 2 gets cancelled. You have a cos x. This goes 0. You have a sin x. So you have a minus cos x by sin x, that is going to be negative cot x. So this negative cot x is your final answer. Okay. Differentiate the following functions from first principles. Sin inverse. So sin inverse type of question we are doing for the first time. So how we are going to do this? Cos inverse theta or sin inverse theta. So this I'll tell you, but if you are willing to solve by yourself, then on the left I have given you reference and you can solve it by yourself. You can check whether you are going correct or not. But those who want to understand how it is being done, so don't worry about anything here. Just there are certain trigonometric relationship that you need to remember, because if you don't know those relationship, you won't be able to solve it. For example, cos A minus cos B, sin A minus sin B, sin inverse x minus sin inverse y, cos inverse x minus cos inverse y. All these needs to be understood. So you have sin inverse 2x plus h. I am applying the first principle. Wherever x is there, x plus h you make and then subtract it with the original function, which is sin inverse 2x plus 3. So sin fx plus h minus fx divided by h I am doing, limit h tends to 0. Limit h tends to 0 and division by h I will be taking wherever it is required. I am not going to write it. So these two I am telling. We will be concentrating on the numerator. Don't leave this. Okay, you have to write this in every step whenever you are solving in the exam or in your classwork. Now sin inverse A minus sin inverse B or sin inverse x minus sin inverse y, that it has a relationship which I am going to tell you that you have to apply here. Without this you won't be able to solve it. Sin inverse x minus sin inverse y is sin inverse x into under root 1 minus y square minus y into 1 minus x square. Okay. So this sin inverse minus sin inverse x minus sin inverse y, this is a relationship you have to follow, and that the x is 2 into x plus h plus 3, y is 2x plus 3. H and limit h tends to 0 I will be taking wherever it is required. So let us take this first term. So we have 2x plus 2h plus 3. And this is the first term. And then we have the second term. Second term was 2x plus 3. So 1 minus 2x plus 3 whole square. Then we have minus y. Y is what? 2x. This y is 2x plus 3. So you write 2x plus 3. And then we have under root 1 minus x is 2x plus 2h plus 3 whole square. So there will be a point where only algebra is required. I am going to leave it for you. Okay? Please remember, because this will take a lot of time. Just understand the steps, the logic. So this is all inside sin inverse. I have not written it up till now, just because I want to show that what is going to be inside. The inside one will be all this, x into under root 1 minus y square minus y into under root 1 minus x square. So now we have sin inverse. Whatever you call it, say sin inverse, whatever is inside, I am calling it as theta. So sin inverse theta by theta is going to be equal to 1. Same as sin theta by theta is equal to 1 when theta tends to 0. So this whole term, if we are going to write it again and again, there is always a possibility in your exam also, because you have limited time, just call it as some z. So this sin inverse, I'm taking everything inside sin inverse and calling it as z. So it is going to be sin inverse z. So if I reduce a z in the denominator, I have to have a z in the numerator also. So whole term, please remember, the z is total term, this whole term which I am saying. So if you have to apply sin inverse theta by theta, then you have to have a z in the denominator and z in the numerator also. So this whole term sin inverse z by z is going to be 1 when you apply limit h tends to 0 in this term. So only z is remaining. That is, whatever is inside sine inverse, that is only left with you to solve. You got the idea? The value or the whole expression, I called it at z. That is the only thing we need to solve, because we know sine inverse z by z is going to be 1 and we have applied it. So we have an under root here. So either you open it, or the best thing is to rationalize it. If you want to get rid of the under root, the best way is to do the rationalization. So just call it as, say, this a and b I am saying. A is the first term, b is the second term. So a minus b, the rationalization is you have to multiply the a plus b and a plus b numerator denominator. So the numerator will get to you a square minus b square, and denominator will give you a plus b. So this whole term I am squaring it. 2x plus 2h plus 3 whole square, and the root of this will be a goner. So it will be 1 minus 2x plus 3 whole square. And then you have a subtraction and b square. So 2x plus 3 whole square, and then under root will vanish. So this is going to be only 1 minus let me write it again, 1 minus 2x plus 2h plus 3 whole square. Now you will be tempted to put h as 0 here and try to solve it so that you get subcertain out of it. A plus b is in the denominator, which I am going to take just now, later. I am just taking the numerator first of all. Okay. So this whole term is nothing but a square minus b square, which I have already written. A plus b, which is the term which I regarded as a or symbolized as a and b, that is going to be in the denominator. But the numerator, I want you to solve it. I hope you will be able to solve, because if you put h as 0, see, I'm just trying to tell you that it is not solvable if you just put h as 0 here and you say, okay, I'm going to solve it. No. If you put h as 0 and you get some untoward situation, then you have to solve it. You have to open all this 2x plus 2h plus 3 whole square. You have to open it, a plus b plus c whole square. You have to know the formula. I'm just putting h as 0 and you will see what will happen. If you put h as 0, 1 minus 2x plus 3 whole square, and minus, again this is 2x plus 3 whole square. Now put h as 0 here. So 1 minus 2x plus 3 whole square. So if you put h as 0 in the numerator, without even solving it, you will get a 0 in the numerator. That is not what we want. Okay. So what I am trying to suggest here is that whole term which I have written, you have to solve it. Okay. So it may take some time for me. That is why I am writing the final solution of this expression of the numerator only. Denominator is a plus b. So see, this denominator will be a plus b. A is what? 2x plus this is going to be 2x plus 2h plus 3, and under root 1 minus 2x plus, this is what I am writing, but this is not correct. This is incorrect. I am saying a plus b. I am writing a square plus b square. A square plus b square won't work. So that is a correction here. I'll just write a plus b. Don't worry. The only thing is this whole term a square minus b square. A I have taken, you know what I have taken. B, you know what I have taken. You have to take a square minus b square. You have to open everything. Okay, this is just algebra. I hope you will be able to do this, and you have to use that h. Once you open it all, then you have to apply h tends to 0. But you don't have to apply it up till now, because the final result will be 4h into h plus 2x plus 3. You need to verify it. Okay, I'm not doing it. I'm just leaving it to you. So you have in the denominator h also. I told you whenever it is required, I'll use it. And whatever is a plus b, I'm writing just as y right now, because we'll be using it. So first let us cancel this h and put h as 0 in the numerator. So you get 2x plus 3. Now in the denominator, I told you y. Okay. Now y is what? A plus b. Simply you have to write this first term a and second term as b. So what this is incorrect. This is incorrect. So a plus b, let me write it. A plus b is what? It is not square. Okay, a plus is simply first term and second term, you add it and put h as 0. Just put h as 0, because when you add them, it is not going to give you 0. So 2x plus 3 will get cancelled. There will be 2 in the numerator, and in the denominator you have 1 minus 2x plus 3 whole square. You can leave it here only. Please remember this term which I have written in the round bracket or showed, you have to solve it by yourself. That is going to give you 4h into h plus 2x plus 3. Then you have to put h as 0 after cancelling this first h from the denominator. 4 into h you have to cancel in the denominator, then only you will get the proper value. Okay, this is all about this exercise. Thank you so much. Take care of yourself.